Okay, I've been just turned on, or I've just been told about Owen Benjamin's site, and he truly is a man's comedian, but I thoroughly enjoy him. And I'm so glad he's on this moon. We couldn't go to the moon bit because anybody that knows anything about physics and math has known, has known there's no way we could have got to the moon. And it doesn't, all the reasons he gives are great. But basically, I'm going to show on Benjamin why simple math shows it's impossible for us as humans made of atoms, which are dipoles, to punch through the glass, shall we call it, the glass or the um, atomic ceiling of the bubble light hole universe that we are encased in. And the reason why, and the ancients knew this, and the everyone at the turn of the century knew this, but somehow everybody's gotten together and decided that they needed to make money with this NASA stuff. And so people either are in the physical sciences are really quite dumb, or they're on with the program. They know to keep mum. They know that looking at these equations, they can see instantly if you are even aware of how physics works, you can see instantly the energy needed to punch through the interior inner orbital atmosphere of this Earth is impossible. Not impossible, but you would need the entire energy of the universe to punch through it. And once you did, we blow up. And this was realized in some of the Werner Von Braun experiments when they realized that they couldn't even get close to Van Allen belts, because the Van Allen belts aren't just radiation. What they are is a hard membrane that basically, once you get close to it, it tears, totally shreds into spaghetti, as they use the term in physics, any material made of atoms. So if any spacecraft got near, even near the Van Allen membrane, you're torn into spaghetti and you can't even go through. Maybe half of you might go through, the other half doesn't, falls to earth. So it is theoretically impossible and physically totally impossible. And they've known this. Otherwise, they've been trying to figure out black holes, and Stephen Hawking just rewrote Schwarzschild's ideas of black holes. But black holes were imagined, and the math was done long ago. In the Rome, they were using the sheer forces of gravity. They knew that they couldn't fight gravity. You had to go with gravity. Werner Von Braun, unfortunately, being the Nazi he was, thought we're going to charge right through gravity, like we're going to hit a moving train and splatter it. No, we're going to be the splatter. The train's going to not even know it hit us. So that's us, us little people, us little Earth versus the gravitational force of the entire universe that is holding our inner atmosphere together. If it did not hold us together by these equations, we would explode like a balloon with a pinprick. And if we sent any aircraft, any spacecraft across that membrane that's holding us like a little corpuscle in this inner Earth atmosphere, we would blow and the whole world would zoom around and collapse into just like a deflated balloon. All right. Think of us as a deflated balloon if we ever sent anything through the Van Allen belt, because it's a belt. Yes, but it's just not radiation. It is a hard membrane like a shell of an egg. Think of cracking in the egg, but think of it exploding, not just dripping out. It explodes like a balloon. So I actually got interested in this about 10 years ago. I'm not a mathematician, I'm not a physicist, but I was watching these programs in which certain experts, quasi experts, were trying to describe gravity. And they were describing gravity as simply a like a ball rolls down a hill. Well, I knew that the ball just doesn't roll down a hill without some force pulling it down the hill, and then it won't go up the hill without some force, opposite force, pulling it up the hill. But these modern day Brian Greens or whoever, they weren't explaining the push pull idea of gravity. There's a repulsion and a attraction, repulsion, attraction. And Newton knew this. This is all in Newton's theories. But somehow, with the introduction of Einstein, everybody forgot that Newton's theories, the attraction, repulsion kind of seesaw motion movement, forgot all about it. So it just became this passive, like roll a ball down a hill, and that's how gravity explained. And then even Brian Greene went to the point of saying, well, it's winding down, but it's going to wind down in like 5 billion years. No, it never winds down. There is some unknowable factor in this universe that keeps the ball rolling, just like the heart. What keeps the heart ticking? Compression, expansion, compression, expansion. Keeps everything moving in the universe, even rolls everything within our bodies, our heart, our brains, our eyes. Compression, expansion, compression, like a choo-choo train. Well, they weren't explaining the motion part of the equation. They were only explaining the architecture. And the two rarely mix because of the way they have designed science. It's like need to know basis. You're over there, you're doing the motion kind of equations. Over here, you're doing the flat architecture. It just, they don't know what each other is doing. They're not speaking the same language, so they can't pull the whole picture together. And that's what happened with Einstein's general relativity. General relativity, as proposed by Einstein, works, but general relativity, as Einstein wrote, is not a mathematical concept. He wrote it as an essay. You can read it. It's about 40 pages long. It's not difficult to understand. In fact, it makes perfect sense if anybody would actually read it. However, Einstein did not actually author the equations. And here we've got general relativity. I'm not discounting Einstein. He wrote a perfectly fine paper on general relativity, though many people don't know this. He did not receive the Nobel Peace Prize, did not receive the Nobel Prize for his theory of general relativity, which is a breakthrough. Other people had been working on it. He just got there first because, of course, he's in the patent office and can kind of see what's going on. But long story short, he's been reputed to have been the first to publish this theory, and it makes perfect sense. However, what doesn't make perfect sense is there aren't any equations that people quite understood at the time to show, well, okay, there's the architecture of the universe, but what about the motion? There's got to be a motion part of it. Well, Schwarzschild is the genius that came up with the equations, and as far as I'm concerned, he and a few others are the seminal thinkers in physics. Meet Carl Schwarzschild. Carl Schwarzschild is like the Elvis Presley of physics. He is, oh, he's the dream boy. He is what you call moon doggy. If you were born in the 60s, here he is. I get heart palpitations just looking at him. Anyway, born in Frankfurt, German, I believe is a German Jew. Hello. Yes, physicist, astronomy. Um, and he was conscripted in World War One, and from a bunker, he had read Einstein, or the physicist at this point in time, during 1914, 1913, during World War I, Schwarzschild actually wrote his field equations describing what Einstein's general relativity predicts. And so he is the one in which all future black hole physics, white hole physics rests. And his beautiful equation, we're going to come down to it. And once you see it, you're going to realize why we can't go to space. Because the energy to punch through the universe is more energy than what the universe has. Okay? Because there's got to be a net negative to hold our universe together. Because what's outside of our universe, just like Russian dolls, keeps going on to infinity. Because there's something, if you know pi never ends. These are they call them the nasty infinities of physics because they never end. And that's God's way of telling us, I'm one step ahead of you, or probably two steps ahead of you. You will never catch up. Just like us in our spaceship, we will never catch up with the speed of light because it's always the same distance ahead of us, no matter what it goes through, no matter how fast we go. We can never overcome or even overcome the difference to close the difference to the speed of light. Because otherwise we explode. And the reason why, we can't hold the energy necessary because light has no substance to it. We have substance. We atoms have to hold themselves together. So if we increase our velocity at the speed of light, we no longer exist. Absolutely mathematically impossible. And physically, if you can see it in your head, which I can, you can't exist as an atom. The atom explodes. That's what speed does. You remember when you watch the old movies when they're getting the airplane pilots are going the speed of sound, right? Breaking through that sound barrier and their face like all drips back and they're like, oh, they're just bracing and their face is just contorting until finally they punch through it. Well, that is what you would need to punch through the inner earth skin, which is called the Van Allen belts. But it's not like sound because once you punch through, the whole world would explode. Unless unless it was like a bump or a bruise and it suddenly healed itself. Might be able to punch through there, but you don't punch through and get anything. What you do is it's like boring through rock. You'd have to bore through space with the energy of a nuclear bore. And I know they've got that equipment because they're boring through rock right now underground, but that's what you have to do. Think of the underground nuclear bores that are boring through the rock, melting the rock, and then pushing through. That's what you have to do in space. You're not going to go speeding in a speeding plane. You're going to be just like underground, trying to bore through with some kind of nuclear bore tool into space. Everyone knows about Stephen Hawking. His contribution was the equation that contributed to the understanding of Hawking radiation. He basically just worked off the work of others and created, like Einstein did, just a different equation to measure radiation that radiates from a black hole versus what energy is needed to pass through a black hole, what energy is needed to go around a black hole. So Hawking's contribution was the radiation patterns that come off a black hole. But in doing this, he was, like he said, Royal Society on the shoulders of giants, which is Schwarzschild. And he started with the Schwarzschild equations And we're going to come down here. I'm going to show you this most beautiful equation. Well, there's several of them that are just, when you understand them, they are just so beautiful. But here's radiation equals 2 masses plus velocity times 2 divided by 8 masses, but that's not really the one. Look, I love equations that deal with time. Time equals, and then all this activity that happens. Now, on this side of the equation, do you know how fast this is? 4 pi. 4 pi, do you understand that has to go 4 rotations in a circle? 2 masses. I mean, if you understand, I'm not going to go through that, but I'm not a physicist. I only studied this for about, I guess, let's see, 18 months. But after I did that, no, not even 18 months, 1 year. But after I did it, I gained such an appreciation for the beauty of these equations. And here's black hole evaporation. To me, that just gives me chills. Even thinking of black hole, just thinking of the energy escaping a black hole is somehow just mystical to me. Interesting, isn't it? And all these equations, I'd have to go back and restudy them, but I just get chills looking at them now, even as I look at, here it is. The beautiful Schwarzschild radius right there. This is the most beautiful equation in the world. The radius times second is 2. Here's G, that's the, excuse me, gravitational constant times mass divided by c squared. So what you've got here is you've got 2 universes, you times their mass, and then you divide it by c squared, because that's how fast 2 circular universes are interacting with each other. That is energy double of our universe. Do you understand that? And then to get it down to to tap that down to the energy of our present universe, you just divide it by c squared. But the energy this would require, and this is what we're saying, you would need this energy of 2 universes first interacting faster and more energy than you can imagine, and then to divide it down to c squared is to tap it down like a transformer, or to reduce it down to its most basic state. That doesn't mean that's not traveling that quickly. All right. That's why our little interior world has to push against, just like a chicken in a yolk in an eggshell. There has to be equilibrium on either side of the equal sign. So the radius of the Schwarzschild per second is going at a rate we can't even imagine. But the only reason they can imagine this is, I guess, they've got the math to do it. I can see it. I just don't have the ability to do the numbers. But for people that I know they want to believe that we could go to space, I knew 10 years ago we couldn't go. We couldn't punch through the interior wall of our little corpuscle or our egg. Think of ourselves as being on the interior of a corpuscle. Just think of a little spirochete invaded that corpuscle. Well, it destroys it. If we actually went to space, we'd destroy our entire ecosystem within the interior of our beautiful, it can be compared to a terrarium. We live in a glass bubble terrarium surrounded by a black hole. And that brings me to Schwarzschild, because what Schwarzschild did to add, excuse me, what Kruskal did to add to Schwarzschild makes everything come into view. So here we have Martin David Kruskal. Look how sweet he looks. I think he looks like a very nice man. And He's still alive. Oh my, no, he died. Oh, 2006. Died before I started studying physics. Okay. Well, I didn't miss visiting him. So, anyway, his contribution brings it all into focus because he developed the Kruskal lattice theory, which states the energy of a black hole is in a lattice configuration. So, what we've got a white hole encased in a black hole. So, just think of the black hole being the shape, the, the shell of an egg, and the white hole being the yolk and the white of the egg. We are living in the white hole, which is the white part and the yolk, and the shell is the black hole lattice configuration. So, in order to punch through this white hole, in order to punch through into the black hole area, you have to have the entire energy of the universe. So I'm just going to leave it there. I'll leave you with some of my videos. They're not the greatest, but you know, it's not rocket science really to understand these equations because I simply start out with, hey, everything has to balance out on equal side of the equal sign. So so if matter, material or atoms is c squared, light is c. So gravity, by process of practical elimination, would have to be c cubed, c3, right? Because c3 equals c plus c squared, right? And then on as far as holding it together, the distribution of energy has to wobble between the two sides, c cubed, c squared c cubed, c squared c cubed, c. So fast it holds it all together as if it is in one perfect crystal. Bing, it's a crystal. Bing. That's our universe. What's out there? I don't know. My suspicion is God's out there. That's just my suspicion and my belief because this thing, this thing we call the universe is so majestic you can't even comprehend it without some sort of inspiring awe. And when you hear all these people that are scientists that are atheists, it's because they have no heart. If they don't have the heart of the lion, they're not going to catch the beauty, the aesthetic quality, the what did Schopenhauer say? Anyway, the beauty of how it all works so incredibly well. So that's my answer to you. It's the equations. Just show them Schwarzschild. Just hey, you got the energy of C cubed? Be my guest. Go to Mars. Be my guest. Go to the moon. See, all it takes is C cubed energy, which of course we have no ability to do. We can't even travel at the speed of light. So tell me how we're even going to get triple the speed of light. It's not going to happen. And Von Braun knew it. The ancient Romans knew it. The Egyptians knew it. We've known this forever. It's just been kept from the public. And this was NASA's Von Braun's, the Nazis' magic. They were the black wizards trying to control the narrative. Oh, I use that word narrative, but it is still, it's crazy because unless you're trained in it, I mean, I'm not trained in it, but this is how they keep the knowledge away is they divide it and then they don't educate us. And so the brilliance of people looking at things is so repressed and stifled. And this is why, and it's all for money. They've done this all for money. Not that we could have been like a million years ahead of now if they hadn't repressed and suppressed this knowledge to the point of just choking off humanity. But my belief now is with the internet, it's going to take off. It's going to take off. And we're sharing more information. That's all there is. Shared information is going to vault us forward in just the most beautiful way.